Hello there, math fans. Dr. Andy Love is going to talk about functions of two variables and what we mean by domain. This is just mostly an introduction to getting used to this notation. Students in my Calculus 3 course have experience with functions of one variable a lot. We're now going to talk about functions of two variables. Okay, so first, and this is always a question I have for students, which is when someone gives you a function and you graph it, what does it mean? And I find sometimes people don't know the answer to that question. In particular, if I give you this function and I draw it, first we have to know the picture. But there's a question of, if this is x, can you label everything else? That's x squared. It's the height. We think of the function as the height. From it, we can get the slope, and there's other things we can do. The same goes for a multivariable function. So we're just going to start with that comment. So let's go down here to something that's equivalent. The biggest difference is the input can be any value of x or y. So you can give me any point down here. So instead of giving me an x, you can give me an x and a y. And then I can ask, what is the z? So I can say, all right, what's the z? And for this first function, the z is x squared plus y squared. And that's basically kind of like this picture over here. This isn't exactly the same, but I have a picture of it, of a paraboloid here. And I have a point I can move around. I've also drawn some things on there, so you could sort of see what are called traces. And we've talked about that a little bit back in 12.6. So anyways, that's what that is. That's the height. So it still means height on your surface. That's what it means. Okay, so that part hasn't changed. That does mean, though, a few things are different in terms of domain. Because here when we talk about the domain, we were talking about intervals. Like when we integrated, we were saying between two places. In 3D, when we talk about domain, so this would be an example of a domain right here of inputs. In this case, the domain of the function is everything. But a domain here could be a region on the ground. And that's really the biggest difference when you switch to multivariable functions. Okay, so we need to talk about regions a lot. So that's the biggest challenge I find students have in chapters 14 and 15 is you suddenly have to think in terms of regions. Now, a lot of the skills in Math 125 apply here. Okay, so there's a couple of examples. So now just to illustrate this idea of regions, I'm going to talk about domain a little bit. Now sometimes that scares students. There's something about words like domain and range that people have gotten worried about because it's a named thing. I'm not sure. Really, the domain is saying, do you understand your functions? And there's not a lot of functions we have that have that many restrictions in our basic toolbox. One function that has a restriction is the square root of something. And the restriction is that the thing under the radical has to be greater or equal to 0. Another function that has a restriction is the log function. The log function is only defined if stuff is greater than 0. There's a few other functions in inverse trig that have domain restrictions, but that's really it. So yes, you have to know your couple functions. Mostly it's those two. The other one is if the denominator can't be 0. But really, if you know those things, you pretty much have it. So when someone says, what's the domain of this? I go, well, why are they asking this? They're asking it because there might be a problem. And the problem is, I can't have 4 minus x be negative. So that's the domain. We often then try to simplify the domain. And that actually helps us graph. That's not going to change in 3D. What is going to change is instead of an interval, it's going to be a region. So let me show you this for this function. If I was going to graph it, I would know that I don't need to plug any numbers smaller than 4. So I'd put a 4 here, and there's going to be nothing over here. This is just a nice way to sort of start to think about functions. I labeled the wrong one. There's going to be nothing over here. X is less than or equal to 4. It's partially how I wrote it. Nothing here. Okay, so here we go. When we plug in 4, we get a 0, and we should sort of know it's a square root. When I plug in a 0, I get a 4. That's it. So you can see it also helps you graph but that's the domain. It's the allowable inputs. And it's an interval. So we would say the interval is everything less than 4, including 4. We allow 4. We're not going to get big into interval notation. It's just about the idea of getting used to working with functions. So how does that change when we do something comparable like this one? And I'll show some visuals of that in a moment. But before I do that, let's do this other one. Okay, so what about the log? The moment you see this, you're asked about a domain, you say, well, you have to have 1 plus x strictly greater than 0, which means x has to be strictly greater than -1. And again, that actually helps you graph. It's the first thing you really should be thinking about. You make a little mark at -1, and then you can graph it. And the log function actually looks like this. There you go. That's the log of 1 plus x. So knowing the domain is just sort of step 1. So again, the goal of this is not to ask you about domains. The goal of this is to get you used to thinking in terms of regions. So here I have two functions. If someone says, tell me the domain of this, I would say, same thing. Y minus x has to be greater than 0, which is the same as saying y has to be greater than x. And that's where things become more interesting, because that's not just an interval, it's a region. Similarly, for this one, if somebody asked me for the domain, I would say y plus x squared has to be greater or equal to 0, which is the same as saying y has to be greater or equal to -x squared. And again, that's what's interesting. Why do I say that's interesting? Because if I went to graph this in 3D, I would not plug in any points where y is less than or equal to x. What do I mean by that? So this really actually helps me think about it. So for g, I would put an x here. This is me looking down at the ground. Now, I would graph this. Now, we could talk a long time about graphing this, but the short answer is you could just graph when they're equal and then test points on both sides. I'm putting a dotted line because it's strictly greater than, but that's y equals x that I just graphed there. You need to shade the side where the y coordinates are bigger. Well, how about when y is 1 and x is 0? So you can graph this. Again, it's not something you spend a lot of energy on. It's just helping us understand regions. And I'll show you some visuals in a second. Okay, same thing. I would like to graph y equals x squared, -x squared. And so I'd graph this. And then I would shade the side. I don't know why I missed. But I would shade the side where y is greater than -x squared. If you can't tell or don't know how, you plot some points. How about 0, 10. Pick something on one side. If I put a 10 here and a 0 here, does it work? Yes. Now, why in the world is that helpful? I'm going to show you here, and then I'll show some visuals. This is actually part of my lecture. I just wanted to show it here. So again, this is all it's asking in the homework. Do you understand when your functions can have an error? And you can see this line I was talking about. The graph only makes sense here. Now, there's always a confusion about the turning when you set this stuff up, because I have the x-axis going this way. So this is that same line. That's that y equals x line. And you can see the graph doesn't exist on the other side. Same thing here. If you graph this, I told you the graph's going to be here. You can see nothing exists here. So let me show you such a thing. I'm going to get rid of some of these pieces. Get rid of all these little weird dots. And now I'm going to show you this surface. So that's the second. This is the second example there. You can see that little piece. So it's the square root of y plus x squared. And that's it. You can see where it's missing. I can label points on there. Here's some points on there. We can talk about their heights. That's it. So that's just getting you to think about picking a value on the ground and what it's equal to. Now, in the next part of it, the way we think about them, the way we visualize them, is this thing called level curves. And I'll talk about that in the next part. But we're going to talk about these curves that touch it and what they mean. Okay, so that's not supposed to be a big thing. It's just an introduction. So you do the homework. You just need those couple things. And it's an introduction to this multivariable notation and just kind of getting you in the feel of Z being your output. All right, hope that helps.